Okay. Okay, and we seem to be live. That's great. Gotta put a little music. All right. That's a little bit of music. Is that too loud? I don't like it. Is that appropriate music? No, I'm fucking stuck on the music. We'll try it, whatever. Okay. Welcome to this reading assignment on binding functions and control flow that will actually cover a lot. Pick up your eloquent JavaScript book and read chapter 2 that starts with programming structure. Stop once you get the sub-chapter about while and do loops. Think about the following questions while reading. What is an expression? What is a binding? What is an environment? What is a function? Yeah, that might be a little... Wow. There we go. Give an example of a function. What is a side effect? Give an example of a function that produces a side effect and another function that produces value. What is control flow? What is conditional execution? What kind of keyword do you need to use to invoke conditional execution? All right, so chapter 2. Excuse me. I think I understand all this. Bindings, chapter 2. This music is not gonna do it. this. What about that? It's a little bit less dominating, I guess. So hopefully it stays that way. I don't know why I'm so hung up on the music today. I don't know. Okay, let's check it out. Check it out. Program structure. In this chapter, we'll start to do things that can actually be called programming. Yay! We will expand our command of the JavaScript language beyond the nouns and sentences fragments we've seen so far, to the point where we can express meaningful prose. Expressions and statements. In chapter 1, we made values and applied operators to them to get new values. Creating values is like creating values like this is the main substance of any JavaScript program, but that substance has to be framed in a larger structure to be useful, so that's what we'll cover next. A fragment of code that produces a value is called an expression. Every value that is written literally, such as 22 or psychoanalysis, is an expression. An expression between parentheses is also an expression. Okay, as is a binary operator applied to two expressions or unary operator applied to one. This shows part of the beauty of a language-based interface. Expressions can contain other expressions in a way similar to how subsentences in human languages are nested. A subsentence can contain its own subsentences, and so on. This allows us to build expressions that can describe arbitrary complex computations. If an expression corresponds to a sentence fragment, a JavaScript statement corresponds to a full sentence. A program is a list of statements. Okay. The simplest kind of statement is an expression with a semicolon after it. This is a program. Okay. It is a useless program though. An expression can be content to just produce a value, which can then be used by the enclosing code. Oh, I'm sorry. Ooh. A statement stands on its own, so it amounts to something only if it affects the world. It could display something on the screen. That counts as changing the world. Or it could change the internal state of the machine in a way that will affect the statements that come after it. These changes are called side effects. The statements in the previous example just produce the values 1 and true, and then immediately threw them away. This leaves no impression on the world at all. When you run this program, nothing observable happens. Boing, boing, boing. In some cases, JavaScript allows you to omit the semicolon at the end of a statement. In other cases, it has to be there, or the next line will be treated as part of the same statement. The rules for when it can be safely omitted are somewhat complex and error-prone. So in this book, every statement that needs a semicolon will always get one. I recommend you do the same, at least until you've learned more about the subtleties of missing semicolons. Bindings. How does a program keep an internal state? How does it remember things? We have seen how to produce values from old values, but this does not change the old values, and the new value has to be immediately used or it will dissipate again. To catch and hold values, JavaScript provides a thing called binding or variable. Let caught equals 5 by 5. There's a second kind of statement. The special word keyword let indicates that this sentence is going to define a binding. It is followed by the name of the binding, and if we want to immediately give it a value, by an equal operator in an expression. The previous statement creates binding called caught and use it to grab a hold of the number that produced by multiplying 5 by 5. After a binding has been defined, its name can be used as an expression. The value of such an expression is the value of the binding that currently holds. Here's an example. Let 10 equals 10. Console log. Okay, I see. I see. When a binding points at a value, that does not mean it is tied to that value forever. The equal operator can be used at any time on existing bindings to disconnect them from their current value and have them point to a new one. Oh, excuse me. Let mood equals light. Console.log mood. Light. Mood equals dark. Console.log mood. Dark. If you let mood be light and you let mood be dark, basically it's letting you change the definition. You should imagine bindings as tentacles rather than boxes. They do not contain values, they grasp them. Two bindings can refer to the same value. A program can access only the values that it still has a reference to. When you need to remember something, you grow a tentacle to hold onto it, or you reattach one of your existing tentacles to it. Let's look at another example. To remember the number of dollars that Luigi still owes you, you create a binding, and then when he pays back $35, you give this binding a new value. Let Luigi's debt equals 140. Luigi's debt equals Luigi's debt minus 35. Okay. Oh man. When you define a binding without giving it a value, the tentacle has nothing to grasp, so it ends in thin air. If you ask for the value of an empty binding, you'll get the value undefined. A single let statement may define multiple bindings. The definitions must be separated by commas. Let 1 equals 2, or let 1 equals 1, 2 equal 2, okay? The words variable and constant can also be used to create bindings in a way similar to let. Variable name equals Ada. Constant greeting equals hello. Greeting plus name is hello Ada. Okay. The first variable, short for variable, is the way bindings were declared in pre-2015 Java. I'll get back to the precise way it differs from let in the next chapter. For now, remember that it mostly does the same thing, but we'll rarely use it in this book because it has some confusing properties. The word const stands for constant. It defines a constant binding, which points at the same value for as long as it lives. This is useful for bindings that give a name to a value so that you can easily refer to it later. Binding names can be any word. They just can be part of binding names. Catch-22 is a valid name, for example, but the name must not start with a digit. A binding name may include $signs or underscores, but no other punctuation or special characters. Words with a special meaning, such as let, are keywords, and they may not be used as binding names. There are also a number of words that are reserved for use in future versions of JavaScript, which also can be used as binding names. The full list of keywords and reserved words is rather long. Okay, don't worry about memorizing this when you're creating a binding products and expected syntax errors. See whenever you're trying to define a reserved word. The environment, the collection of bindings and their values that exist at a given time, is called the environment. When a program starts up, this environment is not empty. It always contains bindings that are part of the language standard, and most of the time, it also has the bindings that provide ways to interact with the surrounding system. For example, in a browser, there are functions to interact with the current loaded website or to read mouse and keyboard input. Functions. A lot of values provided in the default environments have the type function. A function is a piece of program wrapped in a value. Such values can be applied in order to run the wrapped program. For example, in a browser environment, the binding prompt holds a function that slows a little dialog box asking for user input. It is used like this. Prompt, enter passcode, okay? Executing a function is called invoking, calling, or applying it. You can call a function by putting parentheses after an expression. You can call a function by putting parentheses after an expression that produces a function value. Usually, you'll directly use the name of the binding that holds the function. These values within parentheses are given to the program inside the function. In the name, the prompt function uses a string that we give it as the next to show in the dialog box. Values given to functions are called arguments. Different functions might need a different number of different types of arguments. The prompt function isn't used much in modern word programming, mostly because you have no control over the way the resulting dialog looks, but can be helpful in toy programs or experiments. The console.log function. In the examples, I use console.log to output values. Most JavaScript systems, including all modern web browsers and Node.js, provide a console.log function that writes out its arguments to some text output device. In browsers, the output lands in the JavaScript console. This part of the browser interface is hidden by default. Really? Most browsers open it when you press F12 or in a Mac command option 1. If that does not work, search through the menus of an item. Developer tools are similar. Yeah, let me try that. No, there it is. Though binding names cannot contain period characters, console.log does have one. This is because console.log isn't a simple binding. It's actually an expression that retrieves the log property from the value held by the console binding. We'll find out exactly what this means in Chapter 4. Return values. Showing a dialog box or written text on the screen is a side effect. A lot of functions are useful because of the side effects they produce. Functions may also produce values, in which case they don't need to have a side effect to be useful. For example, the function math.max takes any amount of number arguments and gives back the greatest. Okay. When a function produces a value, it is said to return that value. Anything that produces a value is an expression in JavaScript, which means function calls can be used within larger expressions. Here, a call to math.min, which is the opposite of math.max, is used as part of a plus expression. When your program contains more than one statement, the statements are executed as if they are a story from top to bottom. This example program has two statements. The first one asks the user for a number, and the second, which is executed after the first, shows the square of that number. Let the number equals number prompt. Pick a number. Console.log. Your number is the square root of plus number times the number. Alright, I understood that. The function number converts a value to a number. We need that conversion because the result of prompt is a string value and we want a number. There are similar functions called string and Boolean that convert values to those types. Here is a rather trivial schematic representation of a straight line control flow. Not all programs are straight roads. We may, for example, want to create a branching road where the program takes a proper branch based on the situation at hand. This is called conditional execution. Okay. Conditional execution is created with the if keyword in JavaScript. In the simple case, we want some code to be executed if and only if a certain condition holds. We might, for example, want to show the square of the input only if the input is actually a number. Pick a number if number dot is nan the number. That one I don't understand. If number dot is nan the number, the if keyword executes or skips a statement depending on the value of the Boolean expression. The deciding expression is written after the keyword, between parentheses, followed by the statement to execute. The number dot is nan function is a standard JavaScript function that returns true only if the argument is given is nan. The number function happens to return nan when you give it a string that doesn't represent a valid number. Thus, the condition translates to, unless the number is not a number, do this. The statement after the if is wrapped in braces. In this example, the braces can be used to group any number of statements into a single statement called a block. You could also have omitted them in this case, since they hold only a single statement but avoid having to think about whenever they are needed. Most JavaScript programmers use them in every wrapped statement like this. We'll mostly follow that convention in this book, except for the occasional one-liner. If 1 plus 1 equals 2, console.log, it's true. Oh my god. Getting distracted. You often won't have code that executes when a condition holds true, but also code that handles the other case. This alternate path is represented by the second arrow of the diagram. You can use the else keyword together with if to create two separate alternate executing paths. Let the number equals number. Prompt, pick a number. If the number dot is nan, which means the number, then your number is okay. Or else, console.log, hey, why didn't you give me a number? If you have more than two paths to choose from, you can chain multiple if-else parts together. Here's an example. The program will first check whenever the number is less than 10. If it is, it chooses a branch show small, and it's done. If it isn't, that takes the else branch, which itself contains a second if. If the second condition, less than 100, holds, that means the number is between 10 and 100, and medium is shown. If it doesn't, the second and last else branch is chosen. The schema for this program looks something like this. While and do loops. Consider a program that outputs all even numbers from 0 to 12. One way to write this is as follows. Output all even numbers from 0 to 12. That works, but the idea of writing a program is to make something less work, not more. If we needed all even numbers less than 1,000, this approach would be unworkable. What we need is a way to run a piece of code multiple times. This form of control is called a loop. Looping control flows allows us to go back to some point in the program where we were before and repeat it with our current program state. If we combine this with a binding that counts, we can do something like this. Let number equal 0, while 0 is equal or less than 12, console.log number equals to number plus 2. A statement starting with a keyword while creates a loop. The word while is followed by an expression in parentheses and then a statement, much like if. The loop keeps entering that statement as long as the expression produces a value that gives true when converted to Boolean. The number binding demonstrates the way a binding can track the progress of a program. Every time the loop repeats number, gets a value that is 2 or more than its previous value. At the beginning of every repetition, it is compared with the number 12 to decide whenever the program work is finished. As an example that actually does something useful, we can now write a program that calculates and shows the value of 2 by the 10th power. We use 2 bindings, one to keep track of our result and one to count how often we have multiplied this result by 2. The loop tests whenever the second binding has reached 10 yet, and if not, updates both bindings. Let result equals 1, and then let counter equals 0. While counter is less than 10, the result equals result times 2. Counter equals counter plus 1. Yeah, I don't get that. Oh, because the counter starts at 0. Okay. Well, and the counter is less than 10. Result is multiplied by 2, and the counter is increased by 1.
Magic music, soft and sweet, charm the... Magic music, soft and sweet, charm the... Magic music, soft and sweet, charm the...
So it says here, alright, what is an okay, think about the following questions while reading. What is an expression? What is a binding? Think a binding is like that tentacle. A function, give an example of a function. Be sure to post your answers in this thread. Chapter 2 that starts with program structure. Stop once you get to the subchapter about while and do loops. In the examples, I've been adding spaces in front of statements that are part of some larger statement. These spaces are not required. The computer will accept the program just fine without them. In fact, even the line breaks in programs are optional. You could write a program as a single long line if you felt like it. The role of this indentation inside blocks is to make the structure of the code stand out. Right, so it's easy to read. In code, where new blocks are open inside the other blocks, it can become hard to see where one block ends and another begins. With proper indentation, the visual shape of a program corresponds to the shape of the blocks inside it. I like to use 2 spaces for every open block, but tastes differ. Some people use 4 spaces and some people use tab characters. The important thing is that each new block adds the same amount of space. See, I personally don't like this. See that? I mean, why is that there instead of here? I don't know. Most code editor programs will help by automatically indenting new lines the proper amount. For loops, which I think is where he wants us to stop. Okay, let's see. Chapter about while and do loops. Let me see, updating bindings, dispatching, comments, Looping a triangle. Oh, I wasn't supposed to read that, and I did. Okay. So it was basically this other chunk. A fragment of prose that produces a value is called an expression. Every value that is written literally is an expression. Okay, a fragment of code that produces a value. This shows part of the beauty of the language-based interface. Expressions can contain other expressions in a way similar to how sub-sentences in human language are nested. So expressions are fragments of code that produce values. If an expression corresponds to a sentence fragment, a JavaScript statement corresponds to a full sentence. Okay. Oh my god. What is binding? Let caught equals 5 by 5. So basically code is going to be the result of that problem. After a binding has been defined, its name can be used as an expression. You have seen how to produce new values from old values. But this does not change the old values, and the new value has to be immediately used. I like the name variable better, actually. What is an environment? Collection of variables and their values. What is a function? A lot of values provided in the default environment have a type of function. A function is a piece of program wrapped in a value. So this value can be applied in order to run the wrap program. For example, in the browser environment, the binding prompt holds a function that shows a little dialog box asking for user input. Prompt, enter passcode. Execute a function is called invoking or calling or applying it. The values between the parentheses are given the program inside the function. Values given to functions are called arguments. Okay, so this will be a whole argument. So the function itself, a lot of the values provided. It's a piece of program wrapped in a value. Defining prop. Also function that knows a little dialog box. Just cut and paste. Oh, I see. Give an example of a function. Well, I don't know. I don't know that very many. I guess I would learn that in a library or something. I can put that. Side effects while doing loops. Showing a dialog box writing text to the screen is a side effect. A lot of functions are useful because of the side effects they produce. Functions may also produce values, in which case they don't need to have a side effect to be useful. Something a function produces. Something it produces. Such as what? Give an example of a function that produces. Give an example of a function that produces a side effect and another function that produces a value. Give an example of a function that produces a side effect. When a function produces a value, it is set to return that value. Anything that produces a value is an expression in JavaScript, which means functions calls can be used within larger expressions. So the opposite of math.max is used as part of a plus expression. More than one statement. The statements are executed as if they are a story from top to bottom. We may, for example, want to create a branching road where the program takes a proper branch based on the situation at hand. It's called conditional execution. Still not an example. Give an example of a function that produces a side effect. Let me see what people wrote. So both of these are functions. Alert and console.log. Showing a dialog box or writing text to the screen is a side effect. Okay.
Alright guys, welcome back, and let's move on and do something cool. Well, up until now the only interaction between JavaScript and the user has been this alert, that we can actually display an alert. Looks like this. And we can insert data here. We can, for example, print variable, or we can print text like this. And you see, it works. Also, something interesting is that we can print text, and then if we write plus and then we add a variable like this, you see that it will print text and then plus 0.5, which was the value of this sum variable. But let's now add more interactivity between the JavaScript code and the HTML, so that we can actually do some cool things. Well, to start off, I would move this whole script tag, I would remove it, and then I would